Good morning, everyone. Myself Sakshi Mittal, Assistant Professor in Department of Electronics and Communication Engineering, AKGEC Engineering College. Today, I welcome you all to this complex topic for Unit 5 for subject Satellite Communication, KEC 062 subject code. And in this lecture, I am going to discuss about the history and the achievements of satellite communication. So we'll start from the starting, like from the scratch, where the satellite communication has, from where we have got the, get invented with the satellite. So first starting with the Aryabhata, it was launched in 19 April 1975. The experiment ended during 5th day in the orbit, and it is around 360 kgs in weight. It was actually the active technological experience in building and operating a satellite system, and this was the India's first indigenously designed and the built satellite. So this was the first satellite we have ever designed in 1975, and it covered the disciplines like the earth science, space physics. Then in 1979, like on 7 June 1979, the Bhaskara, the first experimental remote sensing satellite, was launched. It was carrying with it the TV and microwave cameras. So if it is having with it the TV and microwave cameras, then it is able to get the applications in the field of astronomy, communication, engineering, earth science. And we can see like the Aryabhata weight was around 360 kgs and Bhaskara weighs around 444 kg. So we can see that if we have installed few more components like the TV and the microwave cameras, the weight of satellite has increased substantially. Then next is the Rohini technology payload. So on 18 July 1980, this was the Rohini technology payload. It was being launched from Satish Dhawan Space Center, Sriharikota. This was only intended for measuring in-flight performance of first experiment flight of SLV-3, the first Indian launch vehicle. So we need to measure the parameters for the satellite. We need to measure the location of the satellite. So we have got some satellites which are used for locating the satellite, like the GPS one. So the GPS helps to locate the satellite by like the 4 satellites will be sending you the signals to the GPS receiver, and with the help of trilateration principle, the GPS receiver location can be located precisely. Same way, if I need to measure the in-flight performance, if I need to measure the performance of the parameters being inside the satellite, then I need to measure, like if I want to check the status of the sensors, cameras, or you can say any electronic component, then it was being launched to measure the in-flight performance of the parameters. But this does not achieve the orbit. So it was just the experimental phase. Then Rohini 1B, it was used for measuring in-flight performance of second experimental launch. Like the Rohini, it was for the first experimental launch of SLV-3, but it did not achieve the orbit. So Rohini 1B, it was launched on 18 July 1980. It is also having the same weight for 35 kg, and it is used for measuring in-flight performance of second experimental launch of SLV-3. It was the first indigenous satellite launch, making it the 7th nation to possess the capability to launch its own satellites on its own rocket. As we have already discussed in our previous lectures, that what is a satellite? If you are sending a satellite to communicate between 2 earth stations, or if you want to, let's say, if you want to broadcast something, then from one earth station you are transmitting something to the satellite, then from satellite you are just receiving it, or you are just sending it back to multiple earth stations if you are in case of broadcasting. So when you are launching a satellite, then first you have got a rocket, and on that rocket, or you can call it as a space shuttle. So on this space shuttle, you have just placed the satellite, and then it is being launched. So after you have got certain stages, like you have got 4 stages to launch the satellite into its particular orbit, and after each stage, the payload, or you can say that the spare parts of the satellite, they are being reflown back to the earth. And if you have got the 2 types of those launch vehicles, you can have the reusable one, or like you have just send it to the earth and then you have flown back to the earth. So there will be types, like the one case, it can be destroyed in the nature, or like in the ocean or sea. Second one, the spare parts, they come back to the earth and they can be reused in the future flights. So we can have these type of launch vehicles. So this Rohini 1B says that by this time, by 1980, we were using the rockets we are hiring the rockets, but this was the first time that we have used our own rocket to launch our satellite. Then Rohini 2, it was launched on 31st May 1981, and you can see the weight of satellite has increased slightly. Like the previous one, it was around 35 kgs. Now we have got the weight around 38 kg. And we can see the weight is very less. It is less than 100 kgs. The reason being that we are just measuring the in-flight performance of the parameters or the sensors, or your maybe the air conditioner, maybe your fans. So whatever parameters you are having inside the spacecraft, so we are going to monitor their performance with the help of this. So we don't need to make it heavy by making it loaded with more of the components. I don't need a camera because if I am doing for a particular application, for Earth station, for Earth observation or the remote sensing, then I need the camera. And if I am being in the communication part, then I need the communication antennas, the repeaters. So all these parameters I don't need. So that's why the weight is slightly less. So this Rohini 2, it was used for conducting some remote sensing technology studies using a landmark sensor payload, and it was launched by the first development launch of SLV-3. So this is a satellite launch vehicle. You can have satellite launch vehicle. Then we like in the previous slide also, I have mentioned that we can have of the two types, whether it is being destroyed in the nature or whether it is flown back to the earth. The INSAT 1A. So the INSAT 1A, it was the first operational multi-purpose communication and meteorology satellite. It was procured from USA and it worked only for 6 months. So INSAT 1A, it was the first communication satellite. So whenever we talk about the satellite, the first name we generally talk is about the INSAT 1A, because it was the first communication of the meteorology satellite. Because when we talk about the satellite, then the first thing that strikes to our mind is that the satellite is being used for the communication purpose. Whenever I have got the terrestrial networks are down, or we have got all the backhaul networks, they are down because of any natural calamity, then in that particular case, satellite communication can be beneficial to provide you coverage for the areas where the connectivity has been lost. So the first satellite we generally think is the INSAT 1A. But it worked only for 6 months, and we all know that satellite generally have a life tenure of 10 to 15 years. So a huge amount of cost is being deployed while launching a satellite from starting stage, from its objective, then building the satellite, designing of satellite, and finally its launching. Then you have to maintain the satellite in its orbit. So a large amount of money is being incurred for that purpose. So if I launch the satellite for a particular operation, like for the communication purpose, then it must operate for 10 to 15 years so that I can get the revenue back. But it only worked for the 6 months. So we can say that it was not that although the launch was successful, but it doesn't operate it for its entire lifetime, like for the 10 to 15 years. So it worked only for the 6 months. So after that, we have got a series of INSAT satellites because it was not that successful satellite. We say that the successful satellite is the one where we are able to recover the revenue we have just invested in designing or building or launching of a satellite. So it was launched on 10 April 1982. And we can say the discipline is communication because it is basically for the communication multi-purpose, and we can say that for the meteorology satellite. And the weight is above 1000 kg, so it weighs around 1152 kgs. Then IRS-1A. IRS-1A is the Earth observation satellite. When we say the Earth observation satellites are generally they are being generally launched in the low Earth orbit. So you launch a satellite at low Earth orbit. So they are the closer one to the Earth, and you can just take the pictures of the various parts of Earth. So if I want them for the remote sensing purpose, maybe for the surveillance, then we can use these satellites. And the another thing is that if I launch a satellite at geostationary orbit, so it is 36,000 km above the Earth's surface, so it is a huge distance. And if you take the pictures from there, the pictures taken at low Earth orbit will be much better. They will be much clearer than the pictures captured at the geostationary Earth orbit. So for the Earth observation or for the remote sensing purpose, generally the satellites are being launched in low Earth orbit. So this was the first operational remote sensing satellite. And after that, we have got a series of IRS satellites. So it was launched on 17th March 1988. And it weighs around 1000 kg. You can say it is approximately around 975 kgs. The second thing is that why we use the we are using the low Earth orbit satellites for remote sensing purpose. So we have seen that the low Earth orbit satellites, they move at a certain velocity, and they have an orbit period for around 90 minutes. So and they will be visible for around 20 minutes. So we can see that at one particular position, the satellite is available for 20 minutes. So after another 90 minutes of the orbit period, they will be again at the same place. So it will be better to obtain the pictures using the low Earth orbit satellites. So they just took parts of the they just took pictures of the parts of the Earth for the observation purpose. If I want to know if it is a land, and after 5 years what it is here. Then OceanSat 1. So this is the Earth observation satellite. It's another Earth observation satellite. It carries an ocean color monitor. We can just say at OCM, and a multi-frequency scanning microwave radiometer. The satellites which we have launched till now, but using the satellite launch vehicle, now this is using the PSLV, that is the Polar Satellite Launch Vehicle, and it was being launched on 26th May 1999. It weighs around 1050 kgs. So like the IRS one, this is also the Earth observation satellite, with the difference that we have got a ocean color monitor and the multi-frequency scanning microwave radiometer attached to the satellite. Then the GramSat 1. GramSat 1, it is the experimental satellite for the first development flight of geosynchronous satellite launch vehicle. We have seen that the last one, the OceanSat, it was using the satellite Polar Satellite Launch Vehicle, and the previous series from Aryabhata to the IRS, they were using the satellite launch vehicles. We have hired, then we have used our own rocket, and now in GramSat 1, we are saying that we are going to use the geosynchronous satellite launch vehicle, that is a GSLV D1. So it was the experimental satellite for the first development flight, but it did not complete its intended mission due to a shortfall in the GTO, that is a geo transfer orbits apogee. It was launched on 18th April 2001, and it covers the discipline of the communication and engineering. It weighs around 1530 kgs. When we launch a satellite, we did not launch it directly into its orbit. If I have to launch a satellite into the geostationary orbit, I cannot directly land that satellite into the geostationary orbit. First, I'll just I have to launch it in some midway. So I can say that first I have to launch the satellite, or I have to land the satellite into the transfer orbit. Maybe I can say that I am first launching a satellite into some parking area. So I have first reached at that particular height, maybe in the low Earth orbit. I've got that parking area. Then from that parking area, we are moving upwards. So we are moving to the orbits. Then we say that while moving, first we have got to the transfer orbit. Like from the transfer orbit, we have to raise the satellite substantially so that as it reaches the geostationary orbit. So when you are in the transfer orbit, we can say that we have got the apogee and the perigee in such a way that one lies in the geostationary orbit, another lies in the GTO, your transfer orbit, which is close to the Earth. So next is the TES. So it was launched on 22nd October 2001. It weighs around 1108 kgs, and it was the experimental satellite to test technologies such as altitude and orbit control system, high torque reaction wheels, new reaction control system, etc. We have said that when we have launched a satellite, After launching a satellite, we need to monitor the satellite. So for what purpose we need to monitor the satellite? We need to monitor the satellite firstly for its location, where it is. And when you talk about the location, you talk about the altitude. At what altitude your satellite is being at currently it is, and in which orbit it is orbiting, it is moving. So you need to monitor the altitude and its orbit. Then when you are talking about the altitude and orbit control system, so we have already discussed in my previous complex topic lectures that in case of altitude and orbit control system, you have to, if you have observed that the satellite is not in the correct position, then you need to just correct the position. So how can you correct the position? For that purpose, I have got a high torque reaction wheels. I can have a spin stabilized satellites. So the spin stabilized satellites, they keep on moving on its own, on its axis. So by just moving on its axis, they will be able to get to the correct position. Or you can have the high torque reaction wheels. So I have got the wheels in the 3 axis, and if I feel that the satellite is just deviated from its current position to the x axis, then the wheel in this particular direction, it will just produce a torque such that the momentum, it will just push the satellite away from this direction, so that it is just moving towards its correct position. So if we have got these subsystems, like the 7 segments or the 7 subsystems we have talked about in the unit 2's complex lecture, so all those subsystems, they need to be monitored. So this was the experiment satellite to test the technologies whichever you are talking about the antenna communication system, power subsystem. So all these subsystems, they need to be monitored. If you have got a torque reaction wheel, they need to be checked whether they are working or whether they have been damaged due to something. So this satellite is particularly used for that purpose. This satellite carries a 1 meter resolution panchromatic camera, and it is considered as a prototype for the future Indian spy satellites. So it is also having with it a 1 meter resolution panchromatic camera. So we can say, as it is going to test the technologies, also it is going to monitor whether everything is working fine or not, and it has got a camera with it. So it can be used for the spy satellites. It can be considered as a prototype for the spy satellites. Then the Kalpana 1 or the METSAT 1, we all are aware about this. It was the first meteorological satellite built by ISRO, Indian Space Research Organization. It was originally named METSAT 1, but the satellite was subsequently renamed after Kalpana Chawla, who had perished in the Space Shuttle Columbia disaster. It was using the Polar Satellite Launch Vehicle. This METSAT 1, it was launched on 12 September 2002. And it weighs around 1060 kg. We all are aware that it was being launched on 12 September. It was having the crew members. The Kalpana Chawla was operating this space shuttle, and it was a disaster, and she has lost her life in that. After that, that METSAT 1, it was renamed as the Kalpana 1. So it was a disaster. So we can say that from the history of the satellite, it is always not the achievements of satellite. Sometimes we have got disasters also. It is not that you have only the success stories. So we have got the failures as well in case of a satellite launch. So it was a major disaster for the space shuttle in Columbia. Then IMS 1, Indian Mini Satellite 1. It was the third world satellite, TWSAT. So till now we are talking about the heavy satellite that weighs around 1000 kgs or even above that. Now we are going to talk about some mini satellites, like with the advent, or we can say with the invent, we have got the weights reduced. We have got the satellite for a particular application. We have got them designed only for a particular prototype. Like this satellite, the Indian Mini Satellite 1, it weighs around only 83 kg. So it is less than 100 kg. So we can call it as a mini satellite. And it was launched on 28th April 2008. It was a low-cost micro-satellite imaging mission, and it was launched as a co-passenger with Cartosat 2A. So generally the satellite designs for mini satellite, they weigh less than 100 kgs, and they have been designed for a specific purpose. So you just launch them as a co-passenger or in the low Earth orbit for just a specific task. Then Chandrayaan 1. So Chandrayaan 1 was launched on 22nd October 2008. It was the India's first uncrewed lunar probe. It carried 11 scientific instruments built and designed by India, USA, UK, Germany, Norway, Poland, Bulgaria. And after a span of 9 months, the lunar craft faced debilitating failure, rendering most onboard systems inoperable. So additionally, the faulty orientation of the SAR resulted in failed experiments, which eventually had to be abandoned. So when it was the India's first uncrewed spacecraft, and it was containing the instruments from various parts. And after 9 months, it becomes inoperable. So this experiment, or this, it was to be abandoned in between, but after few years, it was again relaunched with the improvements in it. So at first, when Chandrayaan 1 was launched, it was a failure. It weighs around 1380 kgs. Then ANUSET 1. This was a research microsatellite designed at Anna University that carries an amateur radio and technology demonstration experiments. It has since been retired. Reset 2 launched as a co-passenger with ANUSET. It was launched on 20 April 2009, and it covers the communication discipline. It weighs around 40 kg. So it is again, if the weight is less than 100 kg, we call it as a mini satellite. But since the weight is less than 50 kg, so we are calling it as a micro satellite. So it was just for the radio technology demonstration purpose. Then the STUDSAT, or the student satellite. It was the first pico satellite. Now you can say the weight is less than 1 kgs. So if the weight is less than 1 kgs, we are calling it as a pico satellite. So as in my first lecture, I have classified the satellite based on their weight. So we have got the heavy satellites, we have got mini, micro and pico satellites. So this one is the pico satellite because the weight is less than 1 kg. So the mass is less than 1 kg. So it was the first pico satellite weighing less than 1 kg. It was designed and developed by a team of 7 engineering colleges in Karnataka and Andhra Pradesh. So the teams from 7 engineering colleges, they have just made a satellite which weighs less than 1 kg, and it was launched as a co-passenger with Cartosat 2B. Then after this, the later Jugnu and SRM sat in 2011, Satyam Bhasat Swayam 1 in 2013, and then Pratham in 2016. So this Swayam 1, they all are the broadcasting satellites. They have been launched in 2013, and then after in 2016, the Pratham was launched. So all these satellites, they were the initiatives from the engineering colleges. So we can say again, the thing we should observe here, it is a satellite which is again being launched as a co-passenger with another satellite. So because if it weighs less than the 1 kg, then that definitely you cannot incorporate more components on it. So you cannot just, if you launch it on a single, if you launch it as it is without any co-passenger with it, if it is launched on its own, then you can see what purpose it can resolve. If it is weighing less than 1 kg, then I cannot incorporate more components on it. I cannot just have the functioning from it. So if it is weighing less, then it needs a passenger or a co-passenger with it. Then ResourceSat 2. So it was launched on 20 April 2011. It weighs around 1206 kg. So I can say it is the heavy satellite. This is ISRO's 18th remote sensing satellite, and essentially it carries on the work begun by the ResourceSat 1. And the YouthSat. YouthSat is another satellite which was launched, or which was designed by the ID Bombay, and it is again as a co-passenger with it. So you can see that we have got a heavy satellite. The heavy satellite is having a co-passenger with it, which is generally the mini satellite. Because mini, micro or your pico satellite, they cannot function. So I have got a resource satellite which is being used for the remote sensing purpose. So it is carrying everything which is required for observing the parts of Earth, and I'm having a co-passenger with it, the YouthSat. So YouthSat will be performing and whatever things it will be requiring, it can just take help from its co-passenger, that the resource set 2. So the discipline it can cover is the earth science and the technology applications. Then IRNSS 1A. IRNSS 1A, it is the first of 7 satellites in the IRNSS navigational system. It was launched on 1st July 2013 and it discipline covers the navigation and global positioning. It weighs around 1425 kgs. So it is one of the heavy satellites. Now you can see that IRNSS 1A is one of the GPS satellites, and for the GPS we say that we need a satellite, we need 4 satellites actually. If I have got a GPS receiver at the earth and I need to get the location, I need to track, my GPS receiver need to be tracked. What this GPS receiver, like in your mobile phones, you have got a GPS receiver. So how your location is being tracked? You have got actually at present 24 satellites are being launched for this purpose and 6 standby satellites. So total 30 satellites are available for locating the GPS receiver all over the world. And your GPS receiver at a time, it must have signal from minimum 4 satellites, and maximum it can get from 12 satellites. So if I am having signals from the 4 satellites, then I say that the 4 satellites, they are sending me the signal. They need to locate me. How will they locate me? They'll just use the principle that they'll send the light waves, and when these light waves will get reflected back. So they'll just observe that these 4 satellites from which you are getting the signal, they are having the atomic clock inbuilt in it. So they are just observing the time period, what it takes to go the signal from the satellite to the GPS receiver and then come back. So it is a twice of the time taken. So they know the velocity at which the light waves travel, and they know the time. So they can just calculate the distance, how far that GPS receiver is from them. And they work on one principle, that the intersection of all the 4 planes, they normally defines the position of the GPS receiver. Obviously, the 4 planes, they may intersect out of the plane somewhere, but obviously that position can be just ignored, and wherever it is intersecting in front, that point, it is generally decides the location of the GPS receiver. We can have some, it is not always accurate, because when you have sent a light wave, it can be reflected if it just strikes maybe another satellite or another planet, then it can just be reflected back. It is not necessarily the GPS receiver from which you have just reflected it back. So IRNSS 1 is basically used for this purpose, for location of GPS receiver, for locating the GPS receiver. So it works when that you should have why I need the 4 satellites? Because I need the location in 3 coordinates, your X, Y, Z, and the 4th one is for the atomic clock. If you have got any error in timing, we are saying that we have got the highly calibrated clocks, but in case there is a timing error, then I need the 4th one, which will measure the error or timing error. Then Mars orbiter mission, or the Mangalyaan 1. So the Mars orbiter mission, or informally we called it as the Mangalyaan, is India's first Mars orbiter. It was launched on 5th November 2013 and it weighs around 1340 kgs. Then Chandrayaan 2 in 2013. After the failure of the Chandrayaan 1, it was again launched. It was such a heavy satellite weighing around 3850 kgs, and it was the India's 2nd lunar exploration mission, because the first mission was unsuccessful. The orbital insertion is successful, but the soft landing is failed. It was the first operational flight of geostationary satellite launch vehicle MK3. So after the failure, because we have seen that after 9 months of operation, the experiment has to be abandoned because it becomes inoperable. So it was again relaunched with improvement in it, and the orbital insertion was successful. But when we say that the orbital insertion, the success of satellite, it is dependent on various factors, whether you have inserted the satellite into the orbit successfully, whether you have reflown the space shuttle back to the earth successfully, it has made a soft landing, and if it has performed its operation for the entire lifetime, like for the 10 to 15 years, for the lifetime it is intended for. Then CMS-02, that is the GSAT 24. So it was the first demand driven satellite of NSIL it was operated by MS Tata Play. It was launched on 22nd June 2022 and covers the discipline like the communication. We all are aware that firstly, we have used to get the cable TVs at our home. So first we have got a traditional network. We are used to get the cable wires at our home that is providing us with broadcast facilities. So we are getting the TV signals, we are catching the TV signals through the traditional cable wires, and after that we have just replaced it with the help of direct broadcasting system. So with the help of direct broadcasting system and your VSAT network, so we have eliminated the traditional cable networks and we have just made the satellites specifically for that purpose, which are just taking the signals from one part and they are giving the signal, the satellite is giving that signal back to the VSAT, a very small antenna per terminal, which is broadcasting it to the multiple users. So you have just replaced the bigger size antenna you have at your earth station with the small antennas, and you have just given a antenna to everybody at their home. Like you have seen the parabolic reflector, you all must be having the parabolic reflectors outside your home to catch the signal from the satellite, and it is having a feed in front of it. So that feed, it is transmitting the signal from that parabolic reflector, it is being reflected back. So when you are receiving the signal, the opposite will happen, that you have received the signal and the feed will transmit it. So same way, this CMS02 or GSET24, it is being used for this purpose by the Tata Play. So this was all about the history and the achievements of the satellite communication. So we have discussed this from the first, the Aryabhatta, and to the satellite being used by the Tata Play in 2022. If you've got any doubt, then you can contact me. Thank you.